finance formula. We're going to need this because the main applications that we look at are to do with finance, superannuation, time payments, things like that. So let's have a look at some finance formula. And the very first basic finance formula you ever would have seen probably is this thing, simple interest, which of course is illegal to use, but we always teach it to you anyway. The simple interest when it comes to finance, I write as PRT. There's different ways of writing it. I is the simple interest, P is the principal, capital R is the interest rate as a decimal, or it could be a fraction I suppose if you wanted to, and T is whatever the time periods are. We're going to invest $3,000 for 7 years at 6% simple interest. How much will it be worth after 7 years? We work out our interest, 3,000 times 0.06 times 7, very simple formula, hence the name, simple interest, 1,260, but this is where you've got to read the question carefully. It says, how much will it be worth? It's not saying what was the interest. So therefore, it's going to be worth $4,260 after 7 years. Compound interest is, of course, what you should be getting, not simple interest. And there is our formula and the tie into the topic. Because if you actually look at the formula, it's a general term of a geometric series. That's why I write it in this form, so it's obvious that is geometric. So AN represents the amount, so it includes the interest and puts it in there as well. P is still the principal. R in this case now is 1 plus the interest rate, so that allows it to compound. And N is still time periods. The other key thing now, because we're compounding, the interest rate and the time periods have got to match whatever the compounding is. Okay, same question, but now we're doing compound interest. $3,000, 6% per annum, compounded annually. So subbing in, and we get 4,510.89. What was the answer to the last one? 4,000. So you can see compound interest is going to give you more money. Well, what would be the difference if it was compounded monthly instead of annually? But now that means the interest rate is going to be 6 divided by 12. Oh, that's quite nice. That was lucky. Hey. And then the number of periods would be 12 times 7, 84. And we get some additional money. Not a lot, but I guess we weren't investing a lot for 7 years, were we? Okay. Now, depreciation is exactly the same. The difference is, instead of adding to one, you're taking away from one because the amount's going down. But really is the same problem. An espresso machine, $15,000. That's one heck of a coffee machine, eh? On the 1st of January 2001, makes life easy, we start with 1. Depreciates 12.5% per annum. What's its value going to be? 2010. Our formula. We have 9 time periods because it's only 9 years. That's why you've got to be careful with these dates. Even though that's 2010 and this is 2001, it's only 9 years because it had all of 2001, then all of 2002, and so it doesn't get 2010 because it's at the start. So the power of 9. Wow, that $15,000 investment in a coffee machine is now worth $4,500. Yeah, well, I suppose 9 years. During which year will the value drop below 10% the original cost? So we want to know, when is our general term less than 1,500? We have another exponential inequality to solve, or more correctly, an exponential inequation to solve. Log both sides, bring n to the power. We're dividing by a log that is less than 1. So if you change the sign, you... Thank you very much, that'll sound wonderful. And we get 17.2. So during the 18th year, 2018, it will drop. Alright, there we go.